This is problem 30 from the electric field. Two neutral metal spheres are insulated from the tabletop they rest on. A positively charged rod is initially far from the spheres. Before each action below, the system is returned to the initial condition. So you have a reading assignment to do today from the OpenStax physics textbook on charging by induction. You can find that if you go to the Physics 261 folder. There's a folder inside that called OpenStax textbook, and you can find the reading in there. Or if you go to the lecture and homework assignments file in our course folder on the M drive, there will be a link to the online version of the textbook there, which will take you right to the section that you want to read for today. There's a little bit of information on the top of that web page on conductors and insulators, which you might find it beneficial to read also. And then it talks about charging by induction. Okay, so we also need to know what a conductor is and what an insulator is. So anytime in your textbook you see metal, they usually use that rather than saying a conductor. So metal is conducting, and in metal and other conductors, charge is free to move. In an insulator, charge is not free to move. An insulator would be something like wood, where the charge is not free to move. Or like plastic. I think in your book, usually if it's an insulator, it will be plastic. Okay, so in a conductor, charge can freely move. In an insulator, charge is not free to move. Okay, and don't forget to do your reading assignment for today. Okay, so in part A, the spheres are near each other, but they do not touch, as you can see in the picture here. The rod is brought near sphere A, but does not touch sphere A. The rod is held at rest near sphere A. Is the net charge on sphere A positive, negative, or zero? This is an example problem in the book, so they actually already put the answer in for you. Okay, so the rod does not touch sphere A. If the rod did touch sphere A, then positive charge from the rod could be transferred onto the sphere. This is like what you're going to be doing in lab when we do the Coulomb's law experiment. So the rod does not touch, so you can't have the positive charge go into sphere A. And the two spheres are initially neutral, which means there is the same amount of positive and negative charge on the sphere. Now, what happens here, if you hold the rod near sphere A, you have positive and negative charges in sphere A. The negative charge is attracted to the positive charge that you have in the rod, so you have negative charge moving over to this side, which leaves you with a net positive charge on this side. Really, it is the negative charges on electrons which are free to move. Even though we know this, sometimes we talk about the positive charge moving because it gives us the same result. Okay, so if we have electrons moving here, the positive charges didn't actually go anywhere, but when the negative charges move here, it leaves us with a net positive charge on this side of the sphere. Then we have electrons in sphere B, which will be attracted to the positive charge on sphere A because that's now closer to sphere B. So sphere B would look something like this. If I'm going to draw this, because the two spheres were neutral, we should have the same amount of positive and negative charge in the sphere. So for every negative sign that I drew, I should have a positive sign as well, which shows us that the spheres are neutral. Because we're looking at the net charge, even though the left side of A has more negative charge, overall the net charge is 0. Your homework, problem 31, looks very similar to 30. For that problem, you can either write 0 or just circle your answer. And for sphere B, for the same reason, that is 0 also. And you can read what they told you there for explaining the reason for your response. Which brings me to something that I should have said before. You should explain your response here. It doesn't have to be as long as what they did in the example problem. For the other problems that we looked at, they would be after this one. Okay, so for this problem here, when it says explain the reasoning for your rankings, this was on problem 35. If by looking at your diagram, I can see how you did your ranking, you don't have to write anything down here. Okay, sometimes you may want to write something down there, like before we had the electric field is, the magnitude of the electric field is proportional to, in this case it would be, it's just proportional to Q because R is the same in each case. You could do something like that. You don't have to give me a long explanation for your rankings as long as I can see from your diagrams what you have done. Okay, so back to problem 30. Okay, so in part B, the spheres touch each other and the rod is brought near sphere A but does not touch sphere A. If it doesn't touch sphere A, the charge from the rod cannot move to sphere A. The rod is held at rest near sphere A. So this is similar to what we saw before, except now A and B are acting like a single sphere. So we have negative charge moving towards sphere B, and the negative charge that was in sphere B now can move into sphere A. And if it was the positive charge that's moving, we could say the positive charge from A moves into B. Or you could say the negative charge from B moves into A and leaves us with B having a net positive charge because the charge wants to be as far away from the rod as it can, and A having a net negative charge. So in this case, even though the rod did not touch the spheres, they end up with individually having A, a positive charge, and B, a negative charge, but A and B together still have a net charge of 0. In part C, the spheres are near each other, but they do not touch, and the rod touches sphere A, the rod is then removed. If the rod touches sphere A and the rod has positive charge, then some of the positive charge from the rod is going to go onto sphere A. And so A is going to have a positive charge, and B is going to have a net charge of 0, even though we're going to have some negative charge on one side and some positive charge on the other, because nothing touched B, the net charge on B is going to be 0. Then, for part D, the spheres touch each other, the rod touches sphere A, the rod is then removed. When the rod touches sphere A, positive charge goes on to sphere A. Then the rod is removed, and we have the two spheres with a net positive charge, and that charge is going to be, after the rod is removed, distributed over the two spheres. If the rod was still nearby, so if the rod was still close, and the rod still has a positive charge and the two spheres are touching each other, where would the positive charge on the two spheres go? It wants to be far away from the rod, so we'd have positive charge over here, and we'd have some negative charge over here. Overall, the two spheres have a net positive charge, so we should have more positive signs than negative signs. Maybe I should put some more there. Okay, here, positive charge went onto the two spheres. Then if the rod is removed, the positive charges want to be as far away from each other as they can, so they're going to spread out evenly over the two spheres. So the net charge on sphere A is positive, and the net charge on sphere B is also positive. Okay, problem 31 is similar, but it's not exactly the same, and there are other things you need to know in order to be able to do problem 31, so you can watch the next video, which is going to be hints for problem 31.